And we're back in better than ever, still in 12.2 chemical calculations. In the last podcast, we introduced you the idea of taking grams to moles, moles to moles, using the mole ratio, and then changing it back into grams. And we ended the podcast, if I scroll back up here, by showing you kind of this extended molar roadmap where you can start with any quantity of, if I just say that this is, I'll just put a star over here, you can start with any quantity of any particular reactant or product and determine any quantity of any other reactant or product. All you have to do is change whatever is given into moles, mole ratio it over to the new substance, and then change it back out of that unit, out of moles, into whatever unit they're asking you to do. And so we're going to go ahead and practice that. Let's scroll down here. Now in the textbook, they give a this particular example right here, where you can start with particles. You can start with mass, you can start with volumes, but again, no matter what is given, you have to change it into moles first. Once you get into your moles of your given substance, you use the mole ratio to change it into whatever else you want. And whenever you're into your moles of your new compound, you can change it into particles using Avogadro's number, changing it into the mass using the molar mass, or changing it into the volume using 22.4 liters per mole, the molar volume at STP. So if this particular diagram helps you out, feel free to look at that as you're doing your homework. Alright, so let's go ahead and try an example problem here. It says, in this we have the combustion of ammonia to produce NO2 and water. And the question is, how many molecules of water could be produced from 2 liters, let's go ahead and fill that in, 2 liters of ammonia. Of course, everything that we're doing right now is at STP. That goes without saying for right now. So here's what we do. Same thing as we've done before. Write down whatever is given. We are starting with 2.00 liters of ammonia. So whatever is given to you, you have to change it into moles. Using your molar roadmap, you know that in order to go from liters to moles, you're going to have to use the molar volume. So 1 mole of ammonia is 22.4 liters. Okay? Let me scroll up and just show you what that looks like. So if we're starting here, okay, in order to get to moles, you got to use the molar volume. Now next, in order to change it over to your next or new compound, you're going to have to use the mole ratio to get it over there. So let's go ahead and do that. The mole ratio to go from, well, we're in ammonia right now and we want to get to water, the mole ratio is a 6 to 4. So we're going to need 6 moles, or we'll produce 6 moles of water from every 4 moles of ammonia, NH3. Now notice so far what we've done is we've canceled out the liters of ammonia, and we've also canceled out the moles of ammonia. Now we're into moles of water. Now what does the question now say? It says how many molecules? Molecules. So in this case, if we're looking for molecules, let's go back up just to show you where we are now. We're into moles. We want to get down to molecules or particles. We have to use Avogadro's number. So let's go ahead and do that. We have 6.022 times 10 to the 23rd molecules of H2O over 1 mole of H2O. The moles of H2O divide out, you're left with molecules. Now notice we started with liters of ammonia, we've canceled them out and changed it into moles. We changed the moles of ammonia into moles of water using the mole ratio, and the question asks us to change it into molecules. We have now done that. We're ready to do the calculation. You take 2 times 1 divided by 22.4 times 6 divided by 4 times Avogadro's divided by 1, and when you perform that calculation, you should get 8.07 times 10 to the 20 molecules, running out of room here, molecules of water. So we haven't done any new calculations than what we've done back from, say, Chapter 10. It is still using the molar roadmap. The only new thing that we have to do is change compounds mid-calculation using the mole ratio. That is the only new thing that we're doing this chapter. All right, let's go ahead and try another one. Using the exact same reaction. How many volume? Well, that doesn't make sense. Let's say what volume? Okay, what volume of oxygen is needed to produce, and let's say 25 grams of NO2. All right, so we're going to do the same calculation. I'm not going to flip back and forth between the molar roadmap this time. You just want to follow along with the molar roadmap that's on the back of your periodic table. We have 25 grams of NO2. That's what we're starting with. Even though it's a product, that's what's given. All right. Now we want to change that into oxygen. Before we do anything, you got to change it into moles. How do you go from grams to moles? You use the molar mass. 1 mole of NO2 has a mass of now in this case here, you are going to have to quick sketch out the molar mass. So nitrogen, NO2, if I do this kind of off to the side, is going to have 14.01 grams per mole plus 2 oxygens at 16 apiece. And so if you do that in your head or with a calculator, you should get 46.01 grams per mole. And so that's the molar mass that we're going to be using here, 46.01 grams of NO2, and then you got 1 mole of NO2. So now the grams of NO2 divide out top and bottom. Now we have to change compounds or species. We got to go from NO2 to O2. To do that, use the mole ratio. It's going to be involving the 4 and the 7. Of course, we want to go into oxygen, so we'll put our 7 moles of oxygen in the numerator. We'll put our 4 moles of NO2 in the denominator so that they can cancel out with the moles of NO2. Now we're into moles of oxygen. The question says, what volume of oxygen is needed? So once you're into moles of oxygen, now we got to go to volume using the molar volume, 22.4 liters over 1 mole. The moles of O2 divide out, top and bottom, and now we've successfully gone from grams of NO2 to moles of NO2. It's always the first step to go to moles. Use the mole ratio to change it from moles of NO2 to moles of oxygen. Use the molar volume to change from moles of oxygen to liters of oxygen. And now if you take 25 times 1 divided by 46 times 7 divided by 4 times 22.4 divided by 1, you should get a volume of 21.3 liters of O2. Of course, that is at STP. All right. So here's what we're going to do, and you can try this, and then we'll give you the answers in the next podcast. Answer the questions using the following reaction. We're going to take, let's say, ethyl alcohol, C2H5OH. It's going to be in the gaseous phase. We're going to react that with oxygen. We're going to need 3 of them for this particular reaction. And we're going to form 2 moles of CO2 gas and 3 moles of water vapor. And here are the questions that I want you to answer using that balanced equation. How many particles of carbon dioxide, CO2, can be produced from 20 grams of oxygen? Okay. And the next question, how many grams of C2H5OH, or ethyl alcohol, are needed to form, let's say, 1.50 liters of water vapor? And finally, how many grams of oxygen will react with 50 grams of the ethyl alcohol, or the ethanol? Okay, go ahead and give those a shot. In the next podcast, we'll go over those answers. We'll see you next time.